You're holding a cup of coffee. Your feet are flat on the floor. Everything around you feels permanent, fixed, obvious. Then, for exactly 10 seconds, gravity switches off. Not weakened, not reduced. Gone. The coffee doesn't spill, it floats. Your body doesn't fall, it drifts. And somewhere deep in your inner ear, a tiny structure that has never once failed you suddenly has no idea which way is up. This isn't science fiction. It's a thought experiment physicists actually use to understand something most people never question. Why gravity feels like the most boring force in the universe when it's actually the one holding your entire biology together. Here's the premise. For 10 seconds, and only 10 seconds, gravity disappears completely across the entire planet. What actually happens to you, to the people around you, and to the world itself? Let's start with your body, because the first few seconds are not what most people expect. You wouldn't scream. You wouldn't even understand what was happening. Your vestibular system, the balance mechanism inside your inner ear, relies on tiny calcium crystals resting on sensitive hair cells, pulled downward by gravity. The moment that pull disappears, those crystals drift freely. Your brain receives a signal that makes no sense. Not falling, not floating, just wrong. Astronauts describe this exact sensation during the first moments of microgravity. Many report nausea, disorientation, a feeling one NASA physician once called sensory conflict. Your eyes say one thing, your inner ear says another, and your brain, for a moment, simply stops trusting itself. Now scale that confusion to every human being on Earth, all at once. But your body is only the beginning. Think about what else was relying on gravity 1 second ago. Water in an open glass. Rain mid-fall. Cars mid-turn. Airplanes mid-flight. Planes wouldn't just float. Their wings depend on airflow generated partly by gravity balancing lift. Remove gravity, and that balance breaks instantly. For 10 seconds, aircraft wouldn't crash, but they would lurch violently as control surfaces fight physics that no longer behaves the way engineers designed for. And here's where it gets stranger. Gravity isn't just pulling things down. It's what gives down a meaning at all. Without it, dust, water droplets, loose papers, unsecured objects, all of it lifts off the ground at once. Not explosively, gently, like the whole world quietly exhaling. For those 10 seconds, Earth would look less like a disaster movie and more like the inside of the International Space Station. Calm, silent, deeply unnatural. Then, 10 seconds end. Gravity returns exactly as it was, and this is the moment scientists actually worry about most. Because everything that lifted gently now falls exactly as fast as it rose. Objects a few feet off the ground land safely, but anything that drifted higher, anything caught mid-air near a ledge, a staircase, a moving vehicle, comes down hard and fast, obeying the same law of acceleration Galileo described centuries ago when he supposedly dropped objects from the Leaning Tower of Pisa. 9.8 meters per second, every second, compounding fast. 10 seconds isn't long, but it's long enough for the human body, untrained and unprepared, to drift a meter or two into open space. Long enough for loose furniture to lift off the floor. Long enough for anyone standing near an edge to become an accident waiting to happen the instant physics turns back on. Here's the part that really should surprise you. The scariest danger isn't the 10 seconds without gravity. It's the one violent second when gravity comes back. This is where the thought experiment quietly teaches something real. We don't actually fear gravity. We fear the absence of it, and then we fear its sudden return. Psychologists have long studied this pattern in a broader sense. Our brains are wired far more strongly to react to sudden change than to a stable, even extreme, condition. Daniel Kahneman's research on loss aversion showed something similar in decision-making. It's not the state itself that disturbs us most. It's the transition. 10 seconds of floating wouldn't traumatize most people. The slam back to normal would. And that reveals something oddly comforting about the force you never think about. Gravity isn't just pulling you down. It's the one constant your nervous system has trusted since before you could form memories. Every reflex, every sense of balance, every instinct about how your body moves through space was built assuming gravity would never blink. Which is exactly why astronauts spend months retraining their bodies after returning from orbit. Even a few weeks without full gravity forces the brain to relearn something it once did automatically. Bone density drops. Muscles adapt. The inner ear recalibrates. What feels instinctive on Earth has to be rebuilt from scratch. So if real astronauts need months to adjust after living without gravity, imagine what 10 sudden seconds would do to 7 billion people who've never trained for it at all. It wouldn't destroy civilization, but it would expose, in the strangest possible way, just how much of what feels solid and permanent about your world is actually one invisible force, quietly doing its job every single second, without ever asking for credit. You're still holding that cup of coffee. It's back in your hand now, warm, ordinary, completely unremarkable. Except now you know the truth. Nothing about it was ever unremarkable at all.